We're going to continue our trigonometry unit, very short unit here, just 3 lessons, uh, today by finding missing sides of right triangles using trigonometry. So, um, we've learned before with right triangles that we can find missing sides with the Pythagorean theorem, but the Pythagorean theorem isn't going to work here on example 1 because we don't know 2 of the sides. You have to know 2 of the sides in order to use Pythagorean theorem. But if we only know one side and one angle, then we can use trigonometry to find either of the other missing sides. Right here, we're going to find side CB labeled x and find the value of x, the length of that side. So here we go. Let's look at what we learned yesterday. SOHCAHTOA, those are our 3 ratios. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Now, the first thing I always look at is the side I'm trying to find. In this case, the side I'm trying to find is opposite of the angle I know, so I'm going to label it opposite. And then I'm also going to look at what side I am given. That 10 is the hypotenuse. Now, the only ratio that uses opposite and hypotenuse is sine. So let's set up an equation. The sine of a 59-degree angle equals its opposite x over its hypotenuse 10. Now, at this point, we can figure out what the sine of a 59-degree angle is either using a calculator set in degree mode or using the table of values that I gave to you in class. And if you don't have it with you, you can find one on the internet probably pretty quickly by searching for trig tables. But the sine of a 59-degree angle is 0.8572. Okay, and then this is a proportion that we're going to solve by just doing cross products here. Just multiply both sides of this equation by 10, and you'll get that x, and I'm going to round this here, x is about 8.6. So that's the length of this side. Now we could go even further. We could find the length of AC. Now that we know 2 sides, we could use the Pythagorean theorem, or we could do adjacent over hypotenuse, which is cosine, to find this side. So let's try this a couple more times. All right, we're given this 41-degree angle, and we're given this side over here is 54. We're trying to find this side. So starting off with SOHCAHTOA, sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. We are trying to find the adjacent side to this 41-degree angle, and we're given the hypotenuse, side across from the right angle. Cosine uses adjacent and hypotenuse. So we'll write our equation. Cosine of a 41-degree angle equals the adjacent side x over the hypotenuse 54. Using the table of trig values, you can find that the cosine of a 41-degree angle is 0.7547. Okay, no matter what the size of your triangle, if you've got a 41-degree angle in there, cosine adjacent over hypotenuse is always going to be 0.7547. And then to solve this, you just multiply both sides by 54. You get about 40.8. That's rounded again. So that's the length of this side. We could use Pythagorean theorem to figure out this third side, or we could use opposite over hypotenuse to figure out that third side if we wanted to. Okay, another one. Starting off with SOHCAHTOA again. We're looking for the side opposite of the angle we know, and we're given the side adjacent to the angle we know. The only ratio that uses opposite and adjacent is tangent. So we'll set this up as the tangent of a 25-degree angle equals the opposite x over the adjacent 103. Use our trig table to find the value of a tangent of 25 degrees, 0.4663, and then just multiply both sides by 103. Comes out to about 48.0. That would be the length of this side. And then we could do Pythagorean theorem to figure out the hypotenuse, or we could do adjacent over hypotenuse. All right. Why don't you guys try this one? Go ahead and press pause on the player and try it by yourself. And when you press play, my solution will be here waiting for you. All right, so I'm assuming you're done with this problem. Let's see if your work matches my work. Always starting off with our three ratios. Doesn't take very long to just scribble these down. We are looking for the side adjacent to this 13-degree angle, and we're given the hypotenuse of this triangle because it's across from the right angle. Cosine is the ratio that uses adjacent and hypotenuse. So we'll write this equation. Cosine of a 13-degree angle equals the adjacent x over the hypotenuse 84. Cosine of a 13-degree angle using our table is 0.9744. And then you just multiply both sides of this equation by 84. And you get that it's about 81.8. All right, so replay any of the video if you don't understand what's going on or how to set up the equations. Come in tomorrow with your questions, and we'll have some practice sheets for you tomorrow as well. Good luck.